Okay, it's 5.3 binomial, 5.3 binomial approximation. So we can use our binomial expansion that we looked at last lecture to approximate large powers of x. So basically, if x is a fraction between -1 and 1, x to any power is going to get smaller as the powers get bigger. So just think, if x was a half, half to the power 2 is a quarter, half to the power 3 is an eighth, half to the power 4 is a 16th, and so on and so on. The fraction gets smaller. So if x is between -1 and 1, as the power gets bigger, the terms will get smaller, which lets us ignore some of the higher powers, and then we can approximate functions and values. So that's what we're going to be doing in today's video. So first question. Right, so we're going to expand this using our binomial expansion in order to approximate 0.975 to the power 10. So I'll show you how we're going to do that. So first of all, we're going to expand this like we were doing last time. So we got 10c1, 10c0, 1 to the power 10, plus 10c1, 1 to the power 9, minus x over 9, power 1, plus 10c2, 1 to the power 8, minus x over 9, power 2, plus 10c2, 1 to the 7, minus x over 9 cubed, and the last one, which we want up to the power 4, 10c3, 1 to the power 6, minus x over 9 to the power 4. So there's our expansion, and we'll go through that now and calculate what each of these terms gives us. So we get 1 minus 10 over 4x plus 45 over 16 x squared minus 120 over 64 x cubed plus 210 over 256 x to the 4. So that's our expansion of 1 minus x over 1 to 10. Okay, that does simplify slightly, so we may as well simplify it. There we go. So now we need to work out the approximation. Basically, to do the approximation, we need to work out what x value makes this bracket equal 0.75 or 0.975. So what x value makes 1 minus x over 9 equal 0.975. And it is usually 0.1 or 0.01, but you always need to check. So in this case, we can quite simply just rearrange this to find x. So if I subtract from each side times 3.9, we do end up with x equals 0.1. So if you like, I can say 1 minus 0.975 equals x over 9. Times that by 9 and you do get 0.1. So there we go. So if we let x equal 0.1, this bracket becomes 0.975. So what we're going to do is say 0.975 here instead. So the power 10 equals all this when x is 0.1. So I'm going to put all my 0.1s in. Here we're going to have 0.1 squared. Here we're going to have it cubed. And here to the power 4. And if we work that out, it's going to give us a really nice approximation to 0.975. Cool, which I think ends up giving us 0.7763. When it's 4 decimal places, 0.7763. And you can check on your calculator what the actual value is. And it does give you the same first 4 digits. Cool, right, let's try another one. So same idea again, expand this, and then work out this one. So we don't need to do the whole thing, I think we'll go up to x squared this time, otherwise we'll be here forever, so. Alright, so if you want to pause the video and give it a go, expand it, find the value of x, might be 0.1, might be 0.01, put in and see if you can approximate 2.05 to the power 7. Cool. So that's our expansion, only 3 terms this time because we're up to x squared already. Now I can work out what each of these are. So we get 128 plus 224x plus 168 x squared. There we go. Now we just need to work out what our x value is. So if we say over here, now we can try and work it out. So if we take 2 from each side, we get 2 is 0.05, so therefore x is 0. So make x 0.1, and we've got a good approximation to 2.05 to the 7. And that will give us 152.08. Cool, right, that's it for today. Watch that through a couple of times. Usually it's x to 0.1. Next year it can change, it gets a bit harder in second year. But basically for this year, just setting those two equal and finding what x has to be. Be careful with your expansion with minus signs, squaring fractions, make sure the whole x value is in the bracket. Other than that though, it should be pretty straightforward. Brilliant.